Greetings everyone, welcome to this channel again. In this video we are going to see operators in Python, specifically Bitwise operators part 2. Again, I would like to inform you that Bitwise operators in Python are used to perform operations on binary representation of integers, and some common uses of this bitwise operator is for low-level hardware manipulation, for data compression and encryption, for network protocols, and for graphics programming. So if you are not of what I have described or not interested in this topic, you may jump and go to the next session. But for the sake of fulfillment, I am going to describe part 2 as well. So let's see the XOR, exclusive OR operator. And the XOR operator with and 5 is 0, 1, 0, 1, and y is 3, and its binary representation is 0, 0, 0, 0, 1, 1. So when we XOR it, when we apply exclusive OR, it becomes 6. How? Let's see it. X is 5, and the representation of 5 is this one, and y is 3, and its representation is this one. And when we XOR it, if they are similar, if the operands are similar, then we put 0. If the operands are different, we put 1. So a 1 and a 1 becomes 0, and a 0 and a 1, since they are different, it becomes 1. 1 and 0 is still different, then it becomes 1. And a 0 and a 0 are similar, then it becomes 0. So this is 6, and in decimal we can find 6, and its binary representation is this one. So the answer is actually 5 XOR 3 is 6. Okay, let's go to the next example for shift, to left shift. So 5 is expected to shift to 3 positions. So let's first let's first shift 1 position, and then the second, and then the third. So in the first shift, left shift 1 position, it becomes 5 becomes 5 becomes, it becomes 10. So how? Let's represent 5 in 8 bits, because when we shift, especially to the left shift, the shift position may go beyond 4 bits. So we need to represent the value in 8 bits, which is 1 byte. So we are forced to represent it in 8 bits. So this is 5, and when we shift 1 position to the left, it becomes 10. As you can see here, shift 1 position to the left, and this comes to the next position, so it becomes 10. Since we are expected to move or shift to 3 positions, we need to do this 3 times. So we have done the first one. Let's do the second one. When we shift to the left again 1 position, it becomes 20. So it becomes 20. This one shifted to the left, and this one also shifted to the left 1 position. Similarly, again we move this 1 position, because we are expected to shift 3 times. This is the last step. So again we shift 1 step to the left and 1 step to the left, and this becomes 14. So the answer is 40. Okay, let's go to the right shift 5, right and 5 to move to the right 3 positions. So we need to go as we have done for left shift. So we need to make it 3 times. So on the first pass, 5, when we move 5 to the right, it becomes 2. And on the second position, on the second shift, it becomes 1, as you can see here. So we are shifting to the right. So when we shift to the right, this becomes 1 again. Third time, when we shift to the right, this becomes 0. So the answer is 0. In short, there is a formula. A left shift by any position, in this particular case by 3 positions, is equivalent to multiplying the number. In this case, the number is 5 by 2 raised to n, which is 5 times to the power of 3. So this is the formula for left shift by any position. Similarly, a right shift by any position is equivalent to integer division, which is actually floor division of the number by 2 raised to n. So the number is 5. This 5 floor division, then 2 raised to 3, which is n by n position. In our case is 3. So using this formula, we can easily find the result. So let's see this using our Jupyter notebook. So as usual, we launch our Anaconda Navigator, and then we come to updatable application and we click on launch. So when we launch, we come to our desktop, and then our folder Python tutorial, and then as usual we create Python file, and let's call it Bitwise part 2. So our example is actually x is equal to 5 and y is equal to 3, I think. So we want to move. Let's first XOR it. Print 5 caret 3. So this is 6. So this is 6. Okay. Similarly, let us try to right shift. This is 5, left shift 3. So what is the value? 40. And let us shift, what is that? 5, 3. So this becomes 0. So the formula says, let's comment, let's use the formula and we will check. So how do we do this? Is the formula said that it is 5 times 2 raised to 3. So 5 times to the power of 3. So this is 5 to 3. Similarly here, 5 floor division, floor division to the power of 3. So since this has highest precedence, let's do it 5 times to the power of 3. So when we enter, it is 40. It is correct. And let's also check the second one, which is 0 actually. Case #2 to the power of 3. So the answer is 0. So the formula is actually correct. We can take another example. Let's take another example. Let it be 4 and let y be maybe, I don't know, 2. So print x XOR. Let's do the XOR first. X caret 2, so it is 6. And let us also do print x left shift 2 or 16. Okay, very good. Okay, let's also check print x right shift 2, so that is 1. So let's use the formula. The formula is like this. The formula is actually what is the number? The number is 4 times to the power of 2 in this case, to the power of 2, and in this case 4 the number times and this to the power of 2. So let's check. So this is 4 times 2 raised to the power of 2. So that is 16. Similarly for and this one and 2, we can 2 raised to, since the power has the highest precedence, so there will not be any problem. So it is, as you can see, it is 1. So 16 and 1. So the formula is correct, and this way we can make our operation on Bitwise. We can make our Bitwise operation using these Bitwise operators. Thank you for watching. Finally, please don't forget to share and subscribe. And thank you for watching. In the next video, we will see our last operator, which is a membership operator. Have a good time.